Hello everybody, this is Professor Iris Miano giving you your Constructions 3 and 4 demonstration. So as you can see, I've got my workspace set up pretty well with all of the tools that I need. Something to write on. I'm choosing some printer paper that I've put on my clipboard. I have a compass, a straight edge, and a pencil is my chosen writing utensil. So here is the procedure that you will want to implement if you need to construct a congruent angle. The first thing that you want to give yourself, of course, is the angle that you want to copy. So this can be any old angle, it can be acute, it can be obtuse, it could be technically a reflex angle, although I think that might be a little bit more challenging. For our purposes though, I'm going to stick to what the book is presenting so that this process can be something that you can replicate just by looking at your textbook. On page 154 is where you'll find the instructions and reference angle, very much along the lines of the one that I'm about to demonstrate. Okay, so we want to give ourselves angle RST. These are the points that they name. So first thing I'm going to do is draw kind of an oblique line between these 2 points. Oh, and excuse me, I mean ray. An oblique ray. And we're going to name them exactly the same names as the textbook. I like to make my S's sometimes look a little bit fancy by having these little extra marks on the edges of them, just so that because sometimes I feel like my S's tend to look like 5s. So there's ray SR, and here is ray ST, and together they form angle RST. So hopefully it's abundantly clear that this is an acute angle, which, if you recall, is an angle that measures less than 90 degrees. So what we're going to do here as our first step is we are going to make so the first step in the instructions is to construct ray PQ as one side of angle NPQ, which we're going to create that's congruent to angle RST, the one that's given. So here's what we're given. In fact, I'm going to go ahead and label it as given, as such. Angle RST, pictured here. And so, to begin the construction, you will want to give yourself ray PQ. Now, ray PQ that you're going to draw over here is going to be analogous to ray ST. So we want to make it horizontal. It does not need to be the same length as the physical representation of this ray right here. But if you wanted to make it the same length, or to make the line segment within the ray the same length, we could go back to construction 1, if you recall. But that's not necessary. The only thing that we need to do is off to the side. I'm going to go ahead and use this area of my writing, my paper, excuse me, I couldn't find the word paper, to begin my congruent angle construction. And again, just to give yourself a point to begin with, and to make it easy on yourself, just give yourself a horizontal ray. And let's just very much quickly, and this is not necessary, but let's say we just wanted to be very thorough in making our angle congruent. So we're going to make a congruent line segment here. So here I'm using my compass to measure the distance from S to T, and I'm going to use that because the angle that I'm about to construct will be named angle NPQ if I'm going to use the book's example. So that'll be PQ. So this is P, And the location of Q, if I'm trying to like be super accurate, will be right here. You see how I did that? I just drew a little tiny bit of an arc on the ray to give myself the exact location that Q should be if I want to be like super duper exact about all of the elements. However, I want to make it abundantly clear that that's not necessary in order to make a congruent angle. It's just, you know, I did that for fun and to call back to construction 1, if you recall. Okay, now what do we need to do here? The construction technically is, with a compass, mark an arc to intersect both sides of angle RST at points G and H. So we can either use this distance here and make an arc in such a way that we go through ray ST and then swing it all the way up to go through ray SR as well. And let's go ahead and do that. We can, there's no reason why we need to change the radius here. We can go ahead and just keep it going through T. Oh, excuse me, and then swing it on all the way up. And look, it happens to also pretty much be going through R as well. Well, actually, if we want to follow the book's example, maybe I'll actually erase this and do it the technical way that they do. All right, so sorry for the deviation, folks. Let me just put this back the way it was. Here's R. Yeah, the way they suggest is the following. Maybe tighten up that compass because we want to create 2 new points. There is a way to do this that doesn't involve creating 2 new points, but if we want to follow the textbook's example, which is something that I said in the initial that I would do, then let's go ahead and do that. So I'm going to tighten up my radius such that in this next arc that I'm about to draw, I'm going to create 2 new points called G and H. And you'll see the purpose of this a little bit later on. So go ahead and swing your compass around in such a way that you intersect with both rays ST and SR, creating new points here and here that will be labeled G and H, respectively. Okay? It's important that we maintain this distance here. And in doing so, we're going to go ahead and move over to our ray PQ that we created for ourselves, and we're going to center at P, and we're going to create a similar arc inside of our perceived interior of the angle that we're about to create over here, or construct the congruent angle. So go ahead and start below PQ ray and swing, all the way up, just to make sure you cover all of the appropriate distance. Like that. Technically you could swing it all the way around and make a circle, but that'll be a little bit of overkill. The next thing you will want to do is possibly adjust your compass such that you capture the distance from G to H over here in the original given angle, okay? So I'm going to need to, for mine, tighten the compass radius such that I capture that distance. Let's see, so you could either center at H or center at G and just make sure that you are going through the, oh, we need to tighten it up a little. Going through that point. Okay, yeah, I like that. You guys see how I am capturing that distance from here to here? Okay. Really, technically you want to center at G, but it should be the same distance this way too, right? Okay, good. So then, once you have found the distance from G to H, you want to come over to ray PQ. Oh, whoops. And I forgot to name this right here. They call it K, which is just an intermediate point to get us to be able to know where to draw the ray for the other half of this angle. And this distance from G to H that we captured here with our compass, that's going to help us get there. So now, capturing this distance from G to H in the original angle, go on over to your angle that you're constructing, center at K, and make an arc that crosses the first arc that you drew in this construction area. All right, and then note the point of intersection. And we will call this, in fact, they don't even name this point over here, but PK, I don't know, we can name it whatever we want. Let's name it L, just to give it a name. L, sure, okay. So this is naming this point anything at all is a slight deviation from the instructions in the textbook, but I don't know, it makes more sense to me to name all of the points that come into play. So we need to now draw a ray connecting P to L. So put an arrow at the end of it, indicating that it is a ray. But then, in order for the name of this angle to be angle NPK, or sorry, NPQ rather, NPQ, we're gonna need to slap another point on here and name it N. NPQ is one possible name for this angle right here. So this is our constructed angle NPQ. So you may notice that these two angles look very, very similar. In fact, they are more than similar, they're congruent to each other. They have the same measure, and so therefore we can categorize them by using the definition of congruency as it pertains to angles. We could call them congruent. So the notation that would be appropriate to link these two angles up together would be that the measure of angle RST is equal to the measure of angle NPQ. And then we can go ahead and make this very definitive statement, which was the purpose of this exercise, was to say that these two angles are indeed congruent to each other. And I want you guys to note the difference in notation here between these two statements. When we're talking about measures of angles, the little m in front of the angle name is necessary, and measures are equal to each other, whereas angles alone, no little m's, we're not talking about measurements, the angles themselves are congruent by virtue as a direct result of the two angles having the same measure. Or vice versa. If you are able to conclude that the two angles are congruent to each other, then you get to claim subsequently, if you like, that their measures are equal. And so in that regard, equal measures and congruency are have a biconditional relationship. You could start with one and conclude the other in whatever order you want. Okay, as long as you have one of them, you can always conclude the other thing. That's construction 3. That's how you make a congruent angle. And I know I'm not proving it because you know what? I do not, full disclosure, have a protractor at my disposal. I know, really bad geometry teacher. But I told you that you would never need one. And that's because we can rely on this process and trust it to be able to make a congruent angle via construction. So, and by via construction, I mean simply using straight edge, writing utensil, and compass. Those are the tools that constructions require, and as long as we have those, we can make a lot of fun things happen. So I'm going to switch gears over with a new page to show you how to create, for a particular angle, an angle bisector. Okay, so here's the next construction. It's called construction 4. And it's an angle bisector. Okay, and it's still, again, on page 154. It's just directly underneath the construction 3 process. Okay, so for this one, we want to give ourselves a similar initial angle. Just an acute angle is probably the easiest one to work with. And you know, you can put this angle like in the middle of your practice space because you're only going to work with one angle. We're going to create some generic angle for ourselves. And by virtue of this process, we're going to bisect it or cut it in half. And because we're going to trust this process, we will know that the ray that we're going to construct inside of this given angle is indeed going to create two interior angles, two inner angles that have the same measure, thereby cutting the given angle in half. So go ahead and give yourselves, see how I just like kind of made this up right here? That's what you want to do. But I recommend, for the ease of this process, that you try and emulate what I've done here and give yourself clearly acute angle, which, just as a reminder, is an angle that measures less than 90 degrees. And they are naming this angle PRT. And so we will go ahead and copy that. Cool. And so what we're going to do, so this is what you're given, is this angle PRT. I almost wrote the name incorrectly. And we're going to construct ray RS, that is the angle bisector for this given angle. So I'm saying ray RS, which bisects angle PRT. And here we go. So go ahead and more or less somewhere within the distance from R to T or R to P, go ahead and open up your compass. Now there's no wrong distance. I'm going to choose to have it be this wide according to you know, the relative size of my angle, okay? And like this first radius really doesn't matter so much. You just want to make it somewhere inside of the other points on the rays that form the angle. So this is what I'm choosing. It's a little bit of a stylistic choice. Again, while you're still learning this process, I recommend that you just kind of more or less follow along with my suggestions, and then as you get more comfortable and you practice these things more and more, you can get a little bit more stylized, I guess I would say, with the process. Okay, so go ahead, and this is one of the fun parts here. Draw an arc with your compass such that you start below ray RT and you swing through the interior of the angle and you end some place above ray RP, like so. So start below, centered at R, swing it around town, okay? And in doing so, with creating this arc, you're going to create 2 points. So go ahead and mark them and call them N and M. Now, where did I get those letters from? I'm literally looking at the instructions in the book, and that's what they name those 2 created points. You may keep this made-up radius that created the first arc to make the next 2 arcs. This is where it gets to be, I think, really super fun, is that in these new locations M and N, what you're going to do are you're going to center at these 2 points. So I'm going to start with M, I guess, for no particular reason, and you're going to make an arc in the entirety of the interior of angle PRT. And this is what I mean by that. Let's start with centered at M, make an arc in the entire interior. Okay, and you're going to do the same thing centered at N, and the 2, this arc and the arc I'm about to draw centering at N are going to intersect with each other. Now you can go all the way, like, you know, inside the interior, or you could simply just intersect. You know, you could make it super minimal and just go boop, that's enough. I just want to intersect with that, you know, second arc that I made. That'll be sufficient as well. You just want to make sure that you capture the intersection point between those 2 arcs. But I like to make, you know, kind of long arcs sometimes. It just is somewhat aesthetically pleasing for the figure. Now, check this out. This point of intersection right here, we're going to call it S. Why is that? Well, because that's going to create a ray RS once I connect R to S in a ray fashion. And that's going to be my angle bisector. So you may notice that it looks like, when I connect these two dots, that I am cutting the original angle, or PRT, in half, and you would be correct. So what can we say about this? This is, okay, so RS indeed does bisect angle PRT, which means that the measure of angle PRS is equal to the measure of angle TRS, if you like, which means that these two interior angles that are now formed within the original main angle are also congruent to each other. This is something else that we can conclude. Isn't that fun? So now you guys know how to bisect an angle, and this process will work for any angle that you are encountering. It'll extend to other angles. They don't have to be acute angles. We just start with that one to, make the process as easy as possible, and also to emulate the book instructions, so that if you want to take a look at the step-by-step process from the textbook in order to give yourself some more practice, it's a familiar process. It's something that you've already done. All right, that is it for these, Section 3.4 constructions. There's definitely more to come, so stay tuned for that. Thank you so much.